Hey guys, we're Team A23, and today we're going to be talking to you about Prodom and Sum Rules for probability. And always remember that you can check www.knoatom.com for more information. Okay, so the product rule and the sum rule are two basic counting principles. So let's start off by talking about the product rule real quick. So the product rule applies when a procedure is made up of separate tasks. So suppose that a procedure can be broken down into a sequence of just two separate tasks. Let's assume that there are n1 ways of doing the first task, and for each way of doing the first task, there are n2 ways of doing the second task. What this means is that there are therefore n1 times n2 ways of doing the procedure. So this is actually quite simple, but let's take a look at a couple examples just to make sure that we understand this. So suppose that I have 4 different shirts in my wardrobe. And in addition to that, I have 3 different pairs of pants. So now using this information, just with shirts and jeans, how many different outfits can I wear? So we look above at the product rule, n1 equals 4, n2 equals 3, and we simply multiply them together, and we can see that there are 12 possible outfits. So it's pretty straightforward, and we can look at a little bit more complex of an example. So let's say that the chairs of a big auditorium are to be labeled, and we want to label them with an uppercase English letter, followed by a positive integer no greater than 100. We want to know the largest number of chairs that can be labeled differently. So, once again, we can use the procedure we used earlier. We see that labeling a chair consists of 2 parts, assigning one of the 26 uppercase letters to a seat. So, let's write that down. The possible number of letters is 26. And then we also want to assign one of the first 100 possible positive integers. So that leaves us 100 numbers. And so for each letter, there's 100 possible choices for that integer. And therefore, we can use the product rule to show that the answer is 26 multiplied by 100, or 2,600 different ways that we can label a single chair in this auditorium. And obviously that leaves us with quite a bit of options, and the product rule really helps us out here. So, now that we have a really basic understanding of the product rule, we can apply it to when there are perhaps more than 2 choices. So let's look at a significantly more complicated example from what we've seen thus far. So let's look at license plates. How many different license plates can be made if every plate is required to contain a sequence of 3 uppercase English letters followed by 3 digits? So, the first thing to do, let's think back to the product rule. And for every option of the first choice, there were corresponding options to the second, which were why we were multiplying together n1 and n2. This time, it's as if we have n1, n2, all the way up to n6. And for every different value of n1, you have to multiply it by all the other values of n2 through n6. So that may sound a little bit complicated, but it's actually simple. Let's break this down. So we know that for the first 3 spots, there are 26 choices. And I'm getting 26 just because there are obviously 26 letters in the alphabet. So, there's 26 choices for each letter, and that's for the first 3. The last 3 are all supposed to be digits, so there are 10 choices for each of those, 0 through 9. So, keeping in mind the product rule, we realize that we actually have to multiply these values together, because every time you change even one of those values, that's a different combination, meaning that we have to account for each individual change. So by multiplying these together, you can get 17,576,000 choices for license plates. And as you can see, although we're using more complicated examples here, it really isn't that hard. It's pretty straightforward. Okay, so that's what we have for the product rule, and now we also need to have a quick discussion about what the sum rule is. Because oftentimes they do kind of contradict each other a little bit. So it will seem pretty simple at first. If a task can be done either in one of n1 ways or in one of n2 ways, where none of the ways in n1 is the same of the ways in n2, then there are n1 plus n2 ways to do the task. So let's look at a quick example to kind of reiterate this. So, for example, let's consider person A has to get to school, and there are a couple possible options for him. Now, his first possible way of getting there is probably walking. And his second way of getting there is to bike. So, obviously, there are two possible ways in front of us. And now let's consider that in this small town, the infrastructure improved, and he now had the choices of taking a car to school, driving, or taking the bus. Now, if you noticed, once again this time, there were different options, but we weren't multiplying the options together. We were simply adding them. And the reason that we did this is because the events are mutually exclusive. We're assuming that he can't walk and bike to school. And so you don't multiply the different possibilities together because they are contradictory. The term is mutually exclusive. So in this situation, all we're doing is just adding together the four ways. And therefore, we can assume that there are four possible ways for person A to get to school. So, once again, to reiterate the sum rule, let's look at perhaps a more complicated example. So, so the question that we now have is, how many ways are there for an integer a to link to any number in a set with n elements, provided that that integer a can be linked to one and only one member of the set? So, one thing to keep in mind here is, well, let's draw our set out. We have a set, and we know that it contains n elements. So we'll draw in element 1, element 2, and then dot, 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 all the way to element n. So, along with that, we have an integer a that can link to one and only one of those. And now the key here is that idea of mutually exclusive that I reiterated in the last slide, and I'll bring it back here again because it's extremely important. The reason that we know to use the sum rule here instead of the product rule is that the integer a can be linked to only one. It can't be linked to m1 and n2 or m2 and m70. It can only be linked to one value of the set at a time. Therefore, the possibilities are we can link a to m1. That's choice 1. Choice 2 is to link a to m2. And obviously you can see the straightforward pattern. It goes all the way up to n. We can link a to mn. And so we can get from this that the choices are just adding up 1 through n, and there are n choices. So all these connections are mutually exclusive, since if one connection happens, the other cannot happen. So we can see here how important it is to understand if an example has mutually exclusive parts to it, and it makes the sum rule very important in real life. So, that's pretty much all the info we have for you today. We really just talked about the product rule and sum rule. To reiterate, the product rule is used when there's a combination of different events that can all happen. And what you do is you basically take the number of choices for each different event and multiply them together. Meanwhile, the sum rule is used when you have a couple of different mutually exclusive events, i.e. n1 cannot occur at the same time as n2. And therefore, you have to just add them together because all that matters is the number of choices that exist in each. So we hope that you enjoyed listening. Thanks very much. And if you need any more help with discrete mathematics work, please check out www.knoatom.com. Thanks for listening.